Alright kids, here we are with 8.4, properties of rhombuses, rectangles, and squares. Okay, these are all special types of parallelograms. Okay, a rhombus is a special parallelogram that has all four sides the same. Just all four sides the same, doesn't have to have anything special about the angles. A rectangle is a parallelogram that has all four angles as right angles. All four angles are congruent and they are right angles. And then a square is what you get when you combine a rhombus and a rectangle. The square is going to have properties of both. It's going to have four congruent sides and four congruent angles. Okay, so all these are parallelograms. A square is a rectangle, but a rectangle is not a square. Kind of like all thumbs are fingers, but not all fingers are thumbs. Okay, a square would be a rectangle, but a rectangle is not a square. Okay, a square meets the definition of a rectangle because it has all the four right angles, or a rectangle doesn't meet the definition of a square because it has the four right angles, but it doesn't have the four congruent sides as well. And here's a little Venn diagram to kind of give you just a little visualization here about our quadrilaterals we've studied here so far. We've got all these parallelograms, and within the parallelogram family we have rhombuses and rectangles, and where rhombuses and rectangles overlap, we get squares. Okay. Some properties here, some corollaries. Remember, a corollary is just a little half step, kind of common sense half step forward off of a definition or a property we already have. So a quadrilateral is a rhombus if and only if it has four congruent sides. Okay, so that's pretty much the definition that we had there. Rectangle corollary. A quadrilateral is a rectangle if and only if it has four right angles. And a square, quadrilateral is a square if and only if it is a rectangle and a rhombus combined. It has to meet the definitions of both. Four right angles, four congruent sides. Okay, those are in your book if you need extra time there to write those down. Alrighty, some special theorems and properties. A parallelogram is a rhombus if and only if its diagonals are perpendicular. Okay, so parallelogram property was that the diagonals bisected. So because a rhombus is a parallelogram, these diagonals are still bisecting, but an added new feature here, because it is a rhombus, one special part is the diagonals will be perpendicular. We didn't have that before. So the diagonals will be they'll still bisect, but now they're going to intersect at a right angle. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Okay. Another thing about these diagonals is that they're going to cut the angles in the corners in half. They're going to bisect the corner angles. This diagonal is going to bisect this angle and this angle. And this diagonal bisects these two corners. And an extra one here for a rectangle. Yes, the diagonals bisect each other, and now with a rectangle, the diagonals, the pieces are going to be congruent. And the diagonals will be congruent as well. So the diagonals are congruent, and then when they bisect each other, then these are going to be congruent. The pieces would be the same. And because a square is a rhombus and a rectangle, all of those would be true for a square. Alright. And we're going to review our biconditional, our if and only if. Recall that biconditionals, such as those theorems we just went through, can be rewritten as two parts. To prove a biconditional, you must prove both parts. Conditional statement. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Converse. if a parallelogram is a rhombus, then its diagonals are perpendicular. So remember, we should be able to prove both of those each way. Okay, think about this one here. For any rhombus, A, B, C, D, decide whether this statement is always or sometimes true. And I think your book will give you the option for never, always, sometimes, or never true. And then draw a diagram and explain your reasoning. Okay? So we got a rhombus, A, B, C, D. Pretty close. These are all the same. Okay? Will A be congruent to C? And how do you know? Well, the answer is yes, and let's think about this. Okay? We might be doing rhombuses, rectangles, and squares today, but these are all special types of parallelograms. And what do we know about parallelograms? Opposite angles are congruent. So that is why. These are all special parallelograms, and one of our parallelogram properties was that opposite angles were congruent. For a rectangle, FGHJ, decide whether the statement is always or sometimes, and we'll throw out never, true. F, G, H, J. G congruent to H. Well, that's going to be true because what's our definition of a rectangle? All four angles have to be congruent. They all have to be right angles. So, yep, those angles are going to be the same. JF and FG. Is that going to be an always or sometimes or never? You might be thinking, oh, never. Okay, this is how the picture is drawn here. Remember that a square is also a rectangle. And if that was the case, then FG would be the same as JF. So that's going to be a sometimes. So you got to put your thinking hats on today. Sketch a rectangle ABCD. List everything you know about it. What do we know about rectangles? Well, number one, we know that a rectangle is a special parallelogram. So all the parallelogram properties are going to be true. And the special thing about this parallelogram that makes it a rectangle is that it has four congruent right angles. Because it's a parallelogram, it also has these properties. Opposite sides are parallel. Opposite sides have to be congruent. And the diagonals will bisect each other. And with a rectangle, we said that we know the diagonals are congruent. So when they bisect each other, the pieces would be congruent. Almost there. Okay, classify, explain your reasoning, and then solve for x and y. So what kind of figure do we have here? Well, four congruent sides, so I'm thinking rhombus or square, 97-degree angle, kind of eliminates square. So it's going to be a rhombus because it has four congruent sides but not right angles. Okay? Then solve. Well, the easy one here is the x's. These two sides are the same, so I'm going to set these equal to each other. We'll get 2 for x. Well, what about y? I don't see any other y's. How am I going to find that? Remember that these special ones are also still parallelograms. So what do you know about consecutive angles in parallelograms? They have to add to be 180. So you could put those equal to 180, or you could do some math here and say, oh, if that's 97, then this one has to be 83. So we get 84 equals 12y, and we'll get 7 for our y value. Okay, number 12. What do we have over here? All the sides are the same. We have 4 right angles. The diagonals are perpendicular. Looks like we got ourselves a square. 4 right angles and 4 congruent sides. The perpendicular diagonals were just a bonus there, but that would have been a property of a rhombus. And then when we put the rhombus and the rectangle properties together, we would know we had a square. Okie dokes, let's see here. Well, the sides have to be the same. So we're going to subtract the 2x, add the 7, and we'll get 4 for x. And then what about our angles? I only see one thing. Okay, because it's a square, and squares have all the properties of rhombus and rectangle. Remember that we bisect the corner angles there, so that's going to be 45. 7y is going to be 42, and we're going to get 6. Homework is 8.4. You're on page 531, 3 through 26, 32 through 37. You'll probably need some graph paper, so make sure you get some graph slips off the back table. Get that homework done.